Continue. So now I'm going to continue with the 80th percentile, right? We're going to calculate the 80th percentile. Yes, I always lose the data set when the meeting ends. I think it was 3, 5, 7, 11, 12, 15. Did I forget something here? And 20. That's what I remember. Did I leave something out? Because they were 8.
Yeah, between 12 and 15, there's 13.
Oh, 13 years. Thank you. Yes, 13. 13. 15. Then 20. 2, 4, 6, 8. So now we're going to calculate the 80th percentile. Eh? We're going to calculate the 80th percentile is equals to n plus 1, then multiply by 0, 80 divided by 100 equals to 0, 0.08. 0.080, né? Which is equals to the n is what? The n is still 8. 8 plus 1. Multiply it by 8 plus 1, you multiply it by 0, 0.8. né? Then you get your answers. 9 multiplied by 0, 0.080. I think it's 7.2. If I'm not mistaken, 7.2. Yes, it's 7.2. Then the AQV, sorry, not the AQV, the APV, because we are dealing with percentiles right now. The APV, okay. The APV plus F multiply by into the NCV minus the APV. Okay. So our approximate percentile value at the 7th position, we're having 7.2. So we're going to check the 7th position from our data set is 1, 2, 3, 4, 5, 6, 7, meaning our APV will be 15. Ne? Then the fractional part of the percentile value will be what? Comma 2, which is equivalent to 0, 2. Okay, then you say 0, 2 multiply by into the NCV, which is the next consecutive value. After 15, it follows 20, meaning it's gonna be 20 minus APV is what? It's 15. Can you quickly punch this in your calculator and tell me the answer, please? 15 plus 0, 2 multiply by 20 minus 15.
16.
What?
16.
15. Okay, meaning your percentile value will be equals to 15. Then you will be done.
No, it's 16.
Yeah?
16.
Oh, 16. Okay. So meaning your percentile value will be 16. So you can even calculate the 50th percentile at your own time, and other percentiles that they have asked. You just use the same procedure. The only thing that you need to change is the fractional part when you're just going to find the position. Because if it is the 50th percentile, meaning it's gonna be 0,50, ne? Just like that. 38, 0,38, 49, 0,49, just like that. 11th, they are mean 87th and 75. So you see, then just like that, you just do them at your own time. Then with the decimals are also having the formula. We're just going to use the very same formula when we're going to look for the decimal values, né? And also need to find the positioning. So using the data set, let's just do only one example for calculating the 80th decile. So 80th decile is more equivalent to 10, right? Meaning we're going to divide it by 10, no longer 100 or no longer 4, because quartile is 4. Then with the percentiles is 100, but with the decimals is going to be equivalent to 10. So let's say that we're going to calculate the 80th decile. 8. The 80th decile is going to be given as n plus 1 multiplied by 0, 0,80. Ne? Remember our 0,80, we find it by saying 8 divided by 10, because in this case we're dealing with the decimals. So we're going to divide by 10. So it's 0,80. So our n is still 8 plus 1, which is equals to 9. 8 plus 1. Then you multiply it by 0, 8. Yeah. Then you get your answer 9 plus 9 multiplied by 0,80. I get 7,2. So basically, if I already get 7,2, I think I'm gonna have the same answer as we're going to get the same answer as the previous percentile. Can you see it? Because at the seventh position we're having 15, and the next consecutive value will be 20. So by the look of things, we're going to get the very same answer from the previous example. So I want to do something different actually. Let's try that one of second decile. The second decile. And then if it is second decile, even here I'm going to change. Meaning it's 2 divided by 10, right? Then 2 divided by 10 is 0,2. We're going to get 0,2 and 0,20. Then your answer is going to get what? 9 multiplied by 0,2, you're going to get 1,8. We're going to get 1,8. Then our formula will be what? Since we're dealing with the decimal, it's going to be ADV, the approximate decimal value, plus the F, which is the fractional part of the decimal position. Then you multiply it by what? Sorry. Multiply it by okay, the N, what's happening? The NCV minus the ADV. Okay, so approximate decimal value will be equals to what? They say that at position number 1, meaning it's gonna be 3. So we're going to say 3 plus the fractional part is 0,8, meaning it's gonna be 0,8. Okay, then multiply by what? The next consecutive value after 3, it follows 5, meaning it's gonna be 5 minus what? The ADV is still 3. What is the answer?
4.6.
4 point, eh?
4.6.
4.6.
Yes.
Okay, then our decimal value will be equals to 4.6. Ne? So can you see now what how do we calculate our decimals? I hope you're also following. Same applies to the fifth decile We're just going to use the same procedure. Just have to convert your positioning, then that's all. If it's fifth best decimal, we're expecting 0.5 because we're saying 5 divided by 10, just like that. Everything, even the third and the fourth decimal, the ninth, the seventh, they're all the same, these things. You see, so there's nothing um, challenging in here. So meaning we're going to be done with the ungrouped data. So let me just try to introduce you to the group data because I don't know how many minutes you're left with. But if then if the 40 minutes ends, then we'll have to stop here for today. Then we'll continue next time. Yeah? So with the group data, we're still going to look at those three central locations. Just that, I mean measures. Just that the only difference is that we are not going to use the very same formulas that we have used in the grouped data. Okay, we're not going to use the very same formulas that we have used in the group data. You see now, for the mean, they're saying that the mean equals to the mean equals to the summation of fi multiplied by the xi divided by n. The summation of fi multiplied by xi divided by n. Meaning in your data set, you will be given the frequencies, right? You will be given the frequencies. The xi simply means the midpoints. So the midpoints, you have to calculate them for you. You have to calculate them on your own. Midpoint equals to the lower limit plus the upper limit divided by 2. Do you see those class limits? Let's say, for example, the first class limit, it says 100 up until 200. I'm giving an example, right? 200 up until 300, which is the second class limit. The third class limit says 300 up until 400. So if we check the first one, it says 100 up until 200. So meaning when we're going to find the midpoint, we're going to say 100 plus 200 divided by what? By 2. Then you find your midpoint. The second one, if it's 200 to 300, you're going to say 200 plus 300 divided by 2, then you find your midpoint. Then at the end, you're going to add all those midpoints that you have, né? And also your frequencies, you're going to add them at the end and write the total. Then the total that you have, let's say the total for the frequencies, you get 20. Okay, and the xi you get, which is the midpoint, the total you get 200. Then you're going to say 20 multiplied by 200 because this is the summation. They say the summation of fi multiplied by the summation of the xi's, meaning you're going to take the sum for the fi, you multiply it with the sum of the midpoints. Then you divide by n, which is the number of observations. Then that will be your mean. Okay. Then with the mode is the number which appears the most, right? From the previous explanation on the grouped data, I mean ungrouped data. We said that this is the number which appears most frequently in your data set. So In this case, because we are talking about the grouped data, the position of the mode is going to be determined by the highest frequency. If we see the highest frequency in our data set, that will be our mode. With the highest frequency, we're going to have the mode, because the value which appears with the highest frequency, it is said to be our what? It is said to be our mode, because it appears most frequently. So that will be our mode, right? Um, then with the explanation of the formula, MO, which stands for the mode, they say that it says the OMO plus the C into the FM minus Fm minus 1. Fm minus 1 is a formula on its own. Ne? This doesn't mean you must subtract 1 here. Fm minus 1 is a formula on its own. Then you divide by 2Fm minus Fm minus 1 minus Fm plus 1. Even Fm plus 1 is the formula on its own. You don't have to tamper with these ones and say plus 1. You take the Fm and add it with 1, it will be wrong. Ne? Then your OMO, what is your OMO? Firstly, you will be determining the value with the highest frequency, right? The value which is having the highest frequency will determine the positioning. The OMO is the lower limit of the modal class interval. After finding that frequency, highest frequency, you are going to get the lower limit of the modal class, because this will be your mode, okay? So if you have the mode, meaning next to that mode or your frequency, highest frequency, you will be having your class limits. Ne? Let's say from 100 up until 200 is your first class limit. And at that class limit, you are having 10 as the frequency. And 10 is the highest value if you compare with other frequencies. Let's say you are having 10, you are having 1, you are having 3. Only these 3 numbers. Ne? So 10 is your highest frequency as compared to 1 and 3. And with 10, the class limit is 100 up until 200. Okay? It's 100 to 200, meaning the lower limit, they say lower limit of the modal class interval. Our lower limit from that will be what? Will be 100, not 200. Because the class limit for that particular frequency, it says 100 and then dash or greater than, less or equals to 200. Ne? So our lower limit of that modal class OMO will be 100. Meaning in here, we're going to substitute 100. Then you go to C. C is the width of the modal class interval. The width is very easy. You just have to determine the difference. In your class limits, we're having the difference. There's no way that you can have the class limits which don't have equal differences or the same differences. Your difference will be constant. If our difference is 100, it will be constant throughout up until the last class limit. So if we say 100 to 200, the next interval says 200 to 300. Can you see that the difference is 100, right? So that is our class width. Meaning in C, we're going to substitute 100. it is the difference. Then our FM they saying that is the frequency of the modal class. Okay, if we said that 10 is the number which appears the most, is the highest frequency, right? And already indicated the lower limit for that particular frequency. Meaning in FM, we're going to substitute that frequency we were talking about, which is 10. Frequency of the modal class, meaning we're going to substitute the 10. FM is going to be equals to 10 minus FM minus 1. FM minus 1 is the frequency of the class preceding the modal class. You must understand it. Fm minus 1. You see, this Fm minus 1 is the formula on its own. They don't say you're going to minus 1. This is just the formula on its own. Okay? Fm minus 1 is the frequency of the class preceding the modal class. Preceding means before, something that comes before in order. Ne? So if 10 is our frequency, right? And is in our first class limit. And our first class limit is 100 up until 200. Meaning that is our first class. So if that it is our first class, I said that, let's say for example, we're having 10 as our frequency in our first class. Second class is 3. Then lastly we're having 1. Okay. Then the class limit says 100 to 200. The second class it says 200 to 300. Then the third class it says 300 to 400. Can you see that? So the frequency of the class preceding the modal interval before 10, there's nothing which comes before 10 because 10 is the first frequency. So there's no way we can have the frequency which is preceding that we cannot see. Ne? Meaning here in Fm minus 1, we're just going to write 0 because we don't have anything. Since 10 is our first value in our frequencies, ne, is going to be 0 here, divided by, let me wrap up, we're left with less than 10 minutes, ne, divided by 2. Fm is the frequency of that modal class. We said that it's 10, meaning it's going to be 10 into 2 into 10 minus Fm minus 1. We said that it's not available. We're going to put 0 minus Fm plus 1. Fm plus 1 is the frequency class following the modal interval. Our modal interval, we said that is at the frequency of 10. Ne? Then I said that, let's say for example, we assume that the next frequency is 3, then the last frequency is 1. So meaning the next frequency, which is the frequency of the class following the modal class, which is Fm plus 1, after 10, meaning it's going to be 3. Meaning Fm plus 1 is going to be 3. We're going to substitute 3. I hope I make sense for the mode. Ne? Then lastly, we're having the median. The median says ME equals to OME plus C into N plus 2 minus F greater than, this is the cumulative frequency. Ne? Cumulative frequency before divided by FME. FME is the frequency of the median class. So if we explain the whole formula, we're having the OME. OME is the lower limit of the median class. Is the lower limit of the median interval. Okay? Lower limit of the median interval. Then the C. The C is the class width. Class width is still the same. Let's say we're still using the very same my data set that I just gave an example about in the mode. Let's say the class width is still 100. Ne? Then into brackets n divided by 2. I told you that whenever you're calculating the median, whenever you're calculating the percentiles, whenever you calculate all the non-central measures, there's no way you can find them without the position. The median, the percentile, the quartile, the decimals. You have to find the position. You don't just decide those measures without finding the position. The position is very much important. Ne? So n divided by 2 is the position. So we're going to say n divided by 2. N is the number of observations. You divide n by 2. So after getting that position, you will go to a data set and look where does your value fall under. Then minus the cumulative frequency of all the interval before the median interval. Meaning this is the value which will come before the median interval. Agree will be finding the median interval. So in the f less than, you're going to substitute the value which comes before that median interval. Then the FME is the frequency of that median interval. After finding the median interval corresponding to it, you will find the frequency of that median interval. And then the lower limit of the median interval also, it will correspond to that particular frequency of the median interval. So you see, the n divided by 2 is the position of your median. The n divided by 2 position. That's how you're going to find your position of your median. Ne? Let's say, for example, n divided by 2. Your n in this case is what? Your n is 20, right? These values are not, I want some different values. Guys, we're only left with 30 minutes, and unfortunately cannot do the calculation today. But for as long as I managed to explain the formulas, I hope when we're going to do when we're going to meet next time and do the calculations, it won't be much of the problem, right? So yeah, we're just going to use these exercises, but you can also try them on your own. And if you don't understand, you can just text me on WhatsApp and ask So if you master these three measures, you will also be done. Then same applies to the quartiles, percentiles, and decimals. Then you'll be done. The rest of others is just the standard deviations, the variance, and also the Bosque and Whisker. And the Bosque and Whisker is what we have been doing, what we've been calculating actually. Because you need the 5 number summary, the minimum value, the maximum value, the upper quartile, lower quartile, and the median. That's what you need. This is what you need. So the Bosque and Whisker is straightforward because if you have learned how to calculate everything, it won't give you much of the problem. So guys, in these 2 minutes, can I ask if you have questions? Because the session will end in any time soon. Any questions that you have? Please make sure that you master you study, because you are going to write from everything that you have done from chapter 1 until the last chapter. So you can see that the work will be much on your side. So try to, especially the examples from the slides, mostly when they set questions, it's either they use um, questions from the slide, examples from the slides, exercises, and also the previous question papers that I've sent to you few days back in the group. Normally they like to repeat questions. The statements might be the same. They might just change the numbers. So guys, this will be the end of our session. We'll meet next time. We'll inform you when we meet. So thank you very much for attending, and have a good, should I say good morning, a good night, yeah, because you are going to sleep now. So thank you very much guys, and sleep well. Bye.